Okay, so hello everyone. So in this lecture I want to discuss one question of your basic elasticity of your aircraft structure. Okay, so I hope you know the importance of basic elasticity chapter, because every year 4 to 5 marks question asked from this chapter only. Okay, so you know the importance, so this is important chapter. So from that chapter I have taken one question for, from the Hooke's law. Okay, so in that we will see how to use the Hooke's law for this, and how to solve the question for this. Okay, so okay, this is for your grade 2023. Okay, and I have taken this question from NPTEL assignment. Okay, NPTEL assignment, and they have asked this question for 2 marks. Okay, so you can expect this kind of question in 2023 also, or in the upcoming year. Okay, okay, let's read the question first. For a beam under pure bending, the strain tensor is given by. Okay, they have given 4 stress tensor option, so we need to pick the right answer. Okay, so let's understand first what they are asking in the question. Okay, so they are saying we have a pure bending case beam we have. Okay, and this is the uh, pure bending case when only moment is rolling in that. Okay, so this is a typical example of pure bending. Okay, and in that, this is the axis we have. I have taken it as a y-axis, and this is x, and this is the cross sectional. Okay, and the length direction, we have a z direction. Okay, this is the length of the beam. Okay, so this is the typical case of pure bending. Okay, let me write it as a pure bending. Okay, and can you tell me what is the shear force in this beam? Please answer me this in comment section, because this is already asked this kind of question. What is the shear force in the pure bending case? Okay, so okay, let's now see what they are asking in this. Okay, so they are asking in the pure bending case which option is correct for the stress tensor. Okay, so if you see pure bending, you will get this kind of stress. In the pure bending case, you will get stress in the z direction. When you try to bend the beam, when you try to bend this kind of beam in this way, the stress is generated in this direction. Okay, this is nothing but z direction for us. Length direction is a z direction. Okay, so only you will get one normal stress, which is your bending stress. Okay, and many time in the question you will find this stress as a bending stress, or you will find it as a normal stress, or you will find it as a direct stress. Okay, so these are the all three names given to it, all are same. Okay, there is no difference. Okay, I hope you understood up till now, till this point. Okay, so when you have a pure bending case, in that case you will only get a one normal stress. Okay, in z direction. So can you tell me what is the Hooke's law? Okay, Hooke's law is nothing but given by this: strain in x direction. Okay, similarly we have strain in y direction. Similarly again we have strain in z direction. So that is dictated by Hooke's law. Associated, you have material property in terms of Young modulus, and in terms of Poisson ratio. When you have these two properties in the material, you will have a strain in all the direction. Okay, so let me write that, and it will be clear to you, and I will explain each and everything in that. Okay, need not to worry. So and because of this three equation, stress tensor is given. Okay, we will find out stress tensor in that. So sigma, when you write for sigma x, this is given by this minus, I will tell you what all this thing is representing. Okay, need not to worry. Let me write first the equation, and this is given by y, this is nothing but y, z is done. Okay, now these are the three Hooke's law for the three direction. Okay, now if you see, when you have a pure bending case, only you will have a stress in z direction. Okay, so according to that, sigma x will be 0, y will be 0, and you will only have this term present in the equation. So this equation will become like this. That means you will get strain in x direction, even though you are not you don't have a stress in x direction, but still you are getting a strain in x direction, presenting that, provided you have a stress in z direction. I hope you got it. So this becomes one equation. Now if you write for the sigma y, strain in y direction, again you don't have this term, so this term becomes 0, you don't have this term, so this term becomes 0, and because you have a z term, you will get strain in y direction. Okay, I hope you understood this also. So what this equation is saying? This equation is saying, even though you are applying even though you are having stress in a z direction, you are getting strain in y direction. Okay, because of this, what is this? This is nothing but Poisson ratio. Because of Poisson ratio in the material, you will get strain in y direction, strain in z direction, strain in x direction. Okay, and sigma z is given by divided by E. This term becomes 0 in that case. Okay, so okay, now understand this carefully. What is the significance of that? You will because of sigma z, because of pure bending, sigma z is induced. Okay, and because of sigma z, you are getting normal strain in z direction. Okay, this is nothing but normal strain. Okay, now you are getting strain in y direction, normal strain in y direction, having negative sign. What does it mean? This is nothing but positive sign, so there is a elongation. Okay, in z direction, and because of negative sign, there will be compression in y direction. Similarly, because of this negative sign, you will have a compression in x direction. That means a normal strain in x direction will be compressive, normal strain in y direction will be compressive, but normal strain in z direction will be, it will not be compressive, it will be elongating. Okay, so I hope you understand what is the significance of this equation and what is it representing. So can you tell me, belonging to these three, which option will be correct in that? So because of pure bending, you are getting strain in x, y, z direction, which are normal strain. So according to that, option 3 is correctly fine. Okay, this is not correct because you are getting this also, x and y, strain x and strain y also getting, which is normal. Okay, this is again also correct. You are not present, they are saying 0 it is. This is correctly fine. This is wrong, this is wrong, because it should be, y should be present in that. Okay, so I hope you understand using Hooke's law, what is Hooke's law and what is pure bending case. Okay, and please answer me, what is the shear force inside the beam throughout the length? What will be the shear force? Okay, please answer me in the comment section. I hope you understand. So NPTEL is, again I am saying, this is a rich website, a rich you can find all those assignment very helpful and handy. You can also, so you can expect those kind of question in your gate exams. Okay, okay, I hope you understood. If not, please ask me in the comment section, I will try to answer there. Okay, let's meet in the next lecture. Thank you guys.